YouTube channel. Today I'm going to discuss about fixed point representation. After that, I will discuss about floating point representation. So why I choose this topic is, so in the real time, real world applications, all the numbers may be some real numbers. So when you want to represent any real numbers in the computers, we require that some kind of format or representation to store the data as a real number in the binary pattern. So see here, in computers, to represent data, this data is not integers. This data is not about integers. It is about real values. So how to represent real numbers in the computers? So real numbers having two parts. One is integer part. Suppose let I'm taking that as familiar one is pi equal to 3.14. Let's say this is the 3.14. So this is called as a decimal point. Decimal point. The point before some digits. This part is called as a integer part, and the digits after the point, this point is called as a fraction part. So how to represent this kind of numbers? Not only 3.14, you can take another number, suppose 7.5 or something 100.25 like this. So if you want to represent any real numbers in the computers, definitely we require some kind of representation. That representation is called as a fixed point. Second one is floating point. So two types of representations are familiar and more use cases. First one is fixed point, and second one is floating point. So the name it says that fixed means, so first before that we should learn about what is point. Okay, so what is this point? When you see that point, I have taken that something binary value or anything in the form of zeros and ones. Let's see, I have taken that 1101 point something 1011. See, this is the point. See means the decimal equivalent of the binary. So this is the point is called as radix point, or in sometimes we call it as a base point. So this point has a fixed position in the number. That kind of number system is called as a fixed point representation. That's why I'm giving that simple definition point of view. See here, the decimal point or a base point or radix point has a fixed position in the number. Fixed position. So fixed or sometimes constant position. So before this point, there is some part is there which is called as integer. Let's see. This is some number. It has an integer part, and this is fractional part. Fractional part. So this point is called as a base point or a radix point. So when you can see, this integer part has some fixed number of digits. Same way, so after this base point also has some fixed number of digits for fractional. So both are having the same fixed number of digits. That's what is called a fixed number representation. So let's come with some examples, and we have seen what are the fixed number representation, and this is mostly widely used in all gaming applications, and also the digital signal process. Okay, and so is this point is fixed? This point is fixed all the times? No guarantee. This depends on the when you want to represent any numbers, like when you want to represent numbers as a signed number system. Signed means numbers having both positive and negative. So if you want to represent signed numbers in computers in the memory, so definitely this point is, this base point is, or base point is repositioned. Is reposition means the position is changes. So with 2 power n scaling factor, so this 2 power n has to decide that, so the value of the number in the real. Let's see that there are three cases are there. A scaling factor, the scaling factor, whether this point is fixed or this point is shift towards to the depends scaling factor. This is maybe, so the position is fixed, the position is fixed or base point is fixed, position or base point is fixed. Okay, base point is fixed. Second case is if this base point is a shift towards to the left or right, to the right. And third case is this base point is shift to the left. What is happening? Which condition are going to be exist in these three cases? Let's see. మనం చూద్దాం ఇక్కడ నుంచి. ఫస్ట్ కేసు ఏంటంటే కేస్ 1. The case 1 is no change in base point. అంటే బేస్ పాయింట్ పొజిషన్ అనేది అసలు ఏం చేంజ్ అవ్వదు అనమాట. సో ప్రీవియస్ ఎలా అయితే ఉందో మనకి స్టోరింగ్ నెంబర్ సిస్టంలో, రిప్రజెంటేషన్ నెంబర్ సిస్టంలో కూడా అలానే ఉంటుంది అనమాట. సో దట్ మీన్స్, సో ఎన్ వాల్యూ ఈక్వల్ 0. ఇక్కడ మనకి ఒకవేళ ఇఫ్ యూ వాంట్ స్టోర్ ద నెంబర్ ఈ సంథింగ్, ఇప్పుడు మనం ఇది స్టోర్ చేసాము, స్టోర్ చేసి ఒకవేళ 1010 అనుకుందాం, ఓకేనా. సో దిస్ ఈస్ ద వాల్యూ విచ్ ఈస్ ఈక్వల్ టు ద 10 ఇన్ ద డెసిమల్. సో మనము ఈ వాల్యూని విత్ స్కేలింగ్ ఫ్యాక్టర్ 2 power 0 తీసుకుంటే, అంటే లైక్ 2 power 0 అంటే ఏమవుతుంది, విచ్ ఈస్ 1. సో 10 into 1 is obviously 10 only. That's why no need to change the position of the base point. సో అందుకని ఏమవుతుందంటే రిప్రజెంటెడ్ నెంబర్ కూడా మనకి 10 వస్తుంది. దట్స్ వై బోత్ ఆర్ సేమ్. సో 10 10 10. సో వెన్ ద స్కేలింగ్ ఫ్యాక్టర్ ఇస్ 0 మీన్స్ no change about this base point. Suppose if you keep suppose point over here, the same in the representation number also. So this is the no change in base point. Second condition వచ్చేసరికి ఏమవుతుందంటే, maybe this base point is shifted to the right side or maybe shifted to the left side. The second condition, base point is shifted to the right. That means scaling factor is n greater than 0. That means whenever we have considered the position value is greater than 0, which is positive, so the base point is shift to the right side. Let's see the scaling factors. Positive means, scaling means factors are nothing but 2 power 1, 2 power 2, like 2 power 3, like this. Okay, so this base point immediately shift towards to the right side. Let's see the example. I have taken that example is, suppose I want to be store the number is 1011. This is the number which is given, which is equal to decimal value is 11 only. So I have taken the scaling factor. నేను స్కేలింగ్ ఫ్యాక్టర్ వచ్చేసి 2 power 1 తీసుకున్నా. అంటే ఏంటి, వన్ టైమ్ పొజిషన్ షిఫ్ట్ చేద్దాం అనుకుంటున్నా. ఎటు షిఫ్ట్ అవుతుంది, పాజిటివ్ ఎప్పుడైతే n ఉంటుందో అది ఆబ్వియస్ గా బేస్ పాయింట్ అనేది రైట్ సైడ్ షిఫ్ట్ అవుతుంది. సో ఎనీ టైమ్ షిఫ్ట్ అయిందో అనే టైమ్స్ అక్కడ ఆ ప్లేస్ లో ఏంటంటే వీ కెన్ రీప్లేస్ విత్ 0. దట్ ఈస్ ఇంపార్టెంట్ థింగ్ ఇస్ ఆఫ్టర్ రైట్ షిఫ్ట్ వాట్ ఈస్ హ్యాపెనింగ్. So this means after right shift by how many positions? There is one position. So that's why by one position the value becomes 1 0 1 1. So we can shift the right time by one position, right? So you can shift the same data to the right side, but whatever the shifting data, that it can replace by the 0 only. So this is becomes the represented number. So after one position shifting, so this is the value which is equal to 22. This means, so our given value is 11, you will get the 22. So how it possible, because of this is multiplied by 2 power 1 position. So this means this simply is a increment the value. So how much increase the value? So this is multiplied by 2. This is scaling by 2. So this is the way you can find out whether the binary or base point is shift towards to the right side. In third case వచ్చేసరికి ఏం చూద్దాం అంటే, if the base point is shift to the left. So whenever n equal to negative, that means less than 0, we consider the scaling factor is always negative numbers. That means 2 power minus 1, 2 power minus 2, like this. Whenever the negative numbers is, what's happening? The base point is shift towards always left side. When you see that, so I am taking that stored number is 10. 10, suppose 1010. What is happening when you can shift towards to the left side with the help of scaling factor? So if you are not defined the scaling factor, మనకి వాల్యూ అనేది లెఫ్ట్ సైడ్ కి బేస్ పాయింట్ అనేది షిఫ్ట్ అవుతుంది అనమాట. సో అందుకని సో వెన్ యూ కెన్ షిఫ్ట్ దిస్ బేస్ పాయింట్, right now the base point over here, it can be shifted by one position. This point is shifting over here. Let's see. So the result is 1 0 1.0 right now. I hope you clear, right? ఇక్కడ మనకి one position shift అవుతుంది అనమాట. This is called represented number. What is happening once you get the result? So the value which is given as input as a 10, okay, but the value which is given as a scaling factor is 2 power minus 1. What is happening? One position is shifting towards the left side. This values could be half of the given number, means so the value should be 5. So how the 10 becomes 5? This is simply as a decrease the value. అంటే వాల్యూ ఏమవుతుంది? తగ్గిపోతుంది. దిస్ ఇస్ ఎంత డిక్రీజ్ అవుతుంది? దిస్ ఇస్ డిక్రీజ్ ద వాల్యూ బై డివైడ్ బై 2. ఇంత టైమ్స్ డిక్రీజ్ అవుతుంది అనమాట. సో దీస్ త్రీ కేసెస్, ఈ మూడు కేసులు మనము స్కేలింగ్ ఫ్యాక్టర్ బట్టి ఒకవేళ బేస్ పాయింట్ అనేది రీపొజిషన్ అవుతుందా లేదా సైన్ నెంబర్ రిప్రజెంటేషన్ గానే చూడాలనుకుంటే ఇలా 3 కన్సిడరేషన్ తీసుకోవాలి. సో అలానే అడ్వాంటేజెస్ వచ్చేసరికి మనకి ఈ బేస్ ఫిక్స్డ్ పాయింట్ రిప్రజెంటేషన్ అనేది డిఫరెంట్ సిస్టమ్స్ యూజ్ చేయొచ్చు. ఆల్ రియల్ టైమ్ అప్లికేషన్స్ లో మనం వీటిని యూజ్ చేయొచ్చు. సో మెయిన్ అడ్వాంటేజ్ వచ్చేసరికి పర్ఫార్మెన్స్ ఇంప్రూవ్ అవుతుంది. సో ఇంప్రూవ్డ్ పర్ఫార్మెన్స్. And next one is so optimized solution. So it will be the optimized solution, and also so there is no hardware, there is no software is required, no need of any hardware, and also no software or software or any models are not required. Come to that, so numbers are represented exactly accurately. So this is today class. I have discussed about fixed point, means the position of the base point is fixed in the number systems. So and we will discuss the floating point number system next video. Thank you.